Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a last numerical based on solutions of differential equation in Laplace transform. Now before moving to last problem, you should know the two much more important things. What are those? ZIR and ZSR. Basically, the today's numerical is also based on ZIR, ZSR and output response. Which one is important in both the cases? That is in ZIR and ZSR. The output produced due to input is nothing but my ZSR, and output produced due to initial condition is nothing but my ZIR. ZIR is, or you can say, initial condition always there on the left hand side, and the ZSR, which is input conditions or output due to input signal, is always on the right hand side. So basically, please go through the statement, please go through the previous video so that you will get the idea. Now we'll move on to numerical number 6. So that is a problem number 6. Problem number 6. Obtain zero input response, that is ZIR. ZSR, that is zero state response, and at the end total response of the system, where the equation is given by d square by dt square of y of t. Now in previous numerical it is mentioned like y double dash of t, which is a second order differentiation. You can write this equation in two ways. Either you can write d by dt or else a y of dash of t. You can use a dash term or else d by dt term. Now look at it. The next one is plus 3 d by dt of y of t. That is a first order differentiation. And the last we have 2y of t equals to x of t. Here u of t or r of t is not mentioned. If u of t is mentioned, which means it is nothing but, or you can say that the unit step signal is given in question. If r of t is mentioned, then please listen carefully. Most of the times they will give you r of t instead of x of t, where r of t is specifically mentioned that it is a ramp wave. If it is not mentioned, then they will give you r of t as a unit step also. R of t is just a function, it is not a ramp wave. So next, now some initial conditions are also given. Y0 is, or you can say y of 0 is 3, and look at here, this is a new term is mentioned, d by dt of y of t, which means a single order differentiation. That is, you can write y dash of t, but here the t value is also given and it is 0, which means this minus 5 is the value of y dash of 0. This is the new way to show that or to represent the y dash of 0. And the last we have x of t value is given, that which is 2u of t, or you can say twice of u of t. U of t stands for unit step signal. Now we'll move on to the next step, that is the solution part. Now we'll apply Laplace transform on both the sides. First of all, I'll calculate Laplace transform of x of t. Basically, x of t is twice of u of t. So Laplace transform x of t is nothing but a twice of Laplace transform of u of t. And we know that this Laplace transform x of t is represented by x of s, whereas u of t Laplace transform is 1 by s. So what is our result? The x of s answer is 2 by s only. Now I'm going to substitute this value over here, as well as I'm going to substitute values of Laplace transform of second order y of t or differentiation of y of t, then the Laplace transform property of first order differentiation of y of t, and at the end the y of s only. This is the Laplace transform of second order differentiation of y of t, s square y of s minus sy of 0 minus y dash of 0. Now this term is nothing but the Laplace transform first order differentiation of y of t, and at the end we have y of s, which is nothing but Laplace transform y of t, and at the end we have equal to 2 by s, and this term we have already calculated. Now I'm going to substitute the values of all the initial conditions in my above or given equation. Now you can open these brackets also. y of 0 is plus 3. Y dash of 0. Look at it. D by dt of y of t, which means this is nothing but y dash. Now the t value is already given and it is a 0. So y d by dt of y of t at t equals to 0 is minus 5, which means this is nothing but the y dash of 0 and the answer is also minus 5. So I'm going to replace this y dash of 0 value by minus 5. Now multiply this 3 inside this bracket as well as substitute the value of y of 0, which is a 3. So you can say that 3 into 3 will gives us a 9. Already here we have a minus sign, so answer is minus 9. And at the end we have 2y of s equals to 2 of s. Now equate all the terms of y of s, or you can say that take y of s common from the left hand side. S square plus 3s plus 2 I have written inside this bracket. Now what is remaining? A constant terms, or you can say that the terms which is produced due to the initial conditions. Now minus s into 3 is minus 3s. Minus minus will gives us a plus 5. And the last one is minus 9. And the rest of the part is 2 by s. Now look at here. Plus 5 minus 9 will gives us a minus 4. You can shift this part on the right hand side. So these two minus sign will be changes to a plus. We have a 2 by s plus 3s plus 4 will be on right hand side, and on the left hand side we have y of s which will be multiplied with s square plus 3s plus 2. Now the much more important term one is what is asked in question. We have to calculate ZIR, ZSR and output response. We'll calculate output response later on, but first of all ZIR and ZSR. Now out of these two, which one will gives us a ZSR value and which one will gives us a ZIR value? The output produced due to input signal is nothing but zero state response. Here 2 by s, or you can say 1 by s is produced due to input signal u of t, which means if I move this s square plus 3s plus 2 on the denominator of 2 by s, then whatever result will be produced, that result will gives us a ZSR value. Now this 3s plus 4 is actually obtained from initial condition, or you can say that this 3s plus 4 is present due to initial condition. If I shift this s square plus 3s plus 2 on the right hand side, or you can say in the denominator of 3s plus 4, then this whole term will gives us a value of zero input response, which means the output produced due to 3s plus 4 will gives us a zero input response, and the output produced due to 2a by s will gives us zero state response. And if we combine both these things, then you will get the total response. Now I have placed the left hand side part on the denominator of each and every term. Now as I told you earlier, this whole term will gives us a ZSR value and this whole term will gives us ZIR value. ZSR means zero state response and ZIR means zero input response. So let's say this is nothing but zero state response value but in terms of s, and this whole term is nothing but zero input response value but in terms of s. I want a response, which means we have to convert both this function into time domain by using inverse Laplace transform. So let's say this is nothing but my equation number 1. My y ZSR of s is nothing but 2 upon s into s square plus 3s plus 2, and y ZSIR of s is nothing but 3s plus 4 upon s square plus 3s plus 2. What is our next step? We are going to calculate ZSR and ZIR separately. Y ZSR of S is nothing but 2 by S into bracket S square plus 3S plus 2. Now we have to calculate the response, which means we need to apply inverse Laplace transform on this equation. But before moving to the inverse Laplace transform, what is important? The partial fraction. And the partial fraction requires some factors. The factors are, the last term is always a product of two digits, and if we add the same two digit, then you will get these middle terms. So 2 into 1 will gives us a 2, but if we add the same two digit, that is 2 plus 1 will gives us a 3, which means our values are S plus 2 and S plus 1. And now here we have a 3 poles, then of course we'll use a 3 variables. And this is nothing but my equation number 2. What is important? Just multiply this left hand side denominator on the right hand side. What you will get? This S will get cancelled. S plus 1 and S plus 2 will be multiplied with A. Similarly, if I multiplied this whole denominator with the B, then S plus 1 will get cancelled. Only B will be multiplied with S and S plus 2. Similarly, if I multiply this left hand side denominator on the right hand side with the C, then S plus 2 will get cancelled. The C will be multiplied with S and S plus 1. So I'm writing that equation. Now, after multiplying this whole denominator with the A, B and C, I have got this equation. What is our next step? We have to calculate the values of A, B, C, but for that you have to replace S by some values. So first of all, I'll substitute S equals to 0. What you will get? Look at here, this B is multiplied with S as well as the C is also multiplied with S. So if I replace this S by 0, then 0 into B and 0 into C, this whole term will become 0. Now, we'll move on to this part. Here this S and S is replaced by 0. So we have only 1 and 2 inside this bracket. And 2 into 1 is 2. So we have twice of A on the right hand side plus 0, which produced by these two terms, and the left hand side we have only the 2. If we shift this 2 on the left hand side, what you can say, this 2 will get cancelled and the answer of A is 1. Similarly, we are going to calculate the values of B as well as C. Now, I am going to substitute S equals to -1 in equation number 3. This was our equation number 3. But look at here. If this S is replaced by -1, then -1 plus 1 becomes 0, and this whole bracket will give us a value 0, and 0 into anything, answer is 0. So A term will not be there in my next step. Look at the last step. If this S is replaced by -1, again the -1 plus 1 becomes 0. So whole term will become 0. So C term will also not there. So we have only 2 on the left hand side and the B equation on the right hand side. Now, the first value is S. So of course I'm going to read it -1. Now the second one. This S is replaced by -1. So 2 plus -1, answer is 1 only. So we have 1 in the next bracket. Now, and the last term, which was 0. 1 into -1, answer is -1. So I can write a minus B because -1 into B is -B. Now just multiply minus sign on both the sides. What you will get? This 2 will be replaced by -2 and this B will be replaced by a plus B. So therefore my B value is -2. Now we will move on to C. Which term you are going to substitute as a place of S? I will place S equals to -2. What you will get? If I substitute S equals to -2, then look at here. -2 plus 2 becomes 0, and as this whole bracket will give us a value 0, so 0 into A, answer is 0. Similarly, look at here. if this s is replaced by minus 2, then minus 2 plus 2 becomes 0, and this whole term will gives us a value 0. So 0 into anything, answer is 0. So only last term is there which will gives us a value, and a and b will be not there. So this s is replaced by minus 2. Now, as this s is also replaced by minus 2, but minus 2 plus 1 will gives us a value minus 1. Now, minus 2 into minus 1, answer is plus 2. So, if I shift this 2 on the left hand side and denominator side, we can say, then 2 will get cancelled and the answer will be 1. So, therefore, my C value is also 1. What is our next step? We are going to substitute the values of A, B and C in equation number. Now, look at here. I have substituted the values of A, B and C. Now, I want to calculate the response, which means we have to apply the inverse Laplace transform on both the sides. I want a response, which means inverse Laplace transform of y of s is y of t. So, y ZSR of s is nothing but y ZSR of. Now, look at here. 1 by s is there, which means it's a simple unit step response. Next term, here we have minus 2 constant, so I'll write minus 2 first, and then at the end we have s plus 1. S plus 1 means s is shifted by 1. So here we'll use a frequency shifting property, and according to frequency shifting property, the answer is e to the power minus t, because here the a value is 1 and we will always multiply a value with a t, but that a value is always opposite sign value. So here a value is plus 1, so answer is minus 1 into 2 is minus t, and what else is remaining? 1 by s, and we know that 1 by s Laplace is unit step. Now, what is the next step? S plus 2. S plus 2 means what? Here again we will use a frequency shifting property. So according to frequency shifting property, this is the value of A and it is plus 2. So look at here. Here we are going to multiply this t by opposite sign value of A. So opposite sign value will be a minus 2. So minus 2 into t is minus 2t. And the next part, 1 by s is remaining, and the 1 by s, the inverse Laplace of 1 by s is unit step. What is important? I'll take unit step common. It is not necessary, but you can take if you want. So if I take unit step common, then this is replaced by, this place is replaced by 1. Now, this will be a minus 2 e to the power minus t and e to the power minus 2. And look at here. I'll mark this one is in my equation number 4. And this is nothing but my zero state response. Now, I'll calculate the next part, which is a zero input response. Y zir of s is nothing but 3s plus 4 whole divided by s square plus 3s plus 2. Now, what we want? A response, which means we have to calculate the inverse Laplace transform. But before moving to inverse Laplace transform, I'll use a partial fraction method to find inverse Laplace technique. So, what we want? The factors, and the factors are, as I already calculated, s plus 2 and s plus 1. So, if we have two poles, which means we will use two variables, let's say that a and b. This is our equation number 5. Now just cross multiply, or simply you can say that just shift this left hand side denominator on the right hand side. So what you can say, s plus 1 will get cancelled, a will be multiplied with s plus 2. Similarly, this s plus 2 will get cancelled if we multiply this whole denominator with b, and so the b will be multiplied with s plus 1. So what is remaining? At the end we have 3s plus 2 on the left hand side, and the right hand side we have s plus 2 into a and b into s plus 1, and this is nothing but my equation number 6. Now, what you are going to do? We are going to substitute the values of s to calculate the value of a and b. So I'm substituting s equals to minus 1 in equation number 6. So all this s is replaced by minus 1. Look at it. In the last step, we have s plus 1. If this s is replaced by minus 1, then minus 1 plus 1 will give us a 0. So 0 is multiplied with b. So whole b term will be removed. Now, look at it. If this s is replaced by minus 1, then 2 minus 1 will give us value 1. Now, on the left hand side, what we have? If this s is replaced by minus 1, then 3 into minus 1 is minus 3, and plus 2 will give us a minus 1. So, what you will get? The a value is minus 1. Now, similarly, we'll calculate the value of b. Now, put s equals to minus 2 in equation number 6. This was our equation number 6. Now, if I replace this s by minus 2, then minus 2 plus 2 becomes 0. So, whole a will be vanished. Now, only b will give us the answer. This s is also replaced by minus 2. This s is also replaced by minus 2. Minus 2 plus 1. Answer is a minus 1. So you can write minus 1 into b is a minus b. Next, 3 into minus 2 is minus 6, and plus 2 will give us a value minus 4. Now if I multiply minus sign on both the sides, what you will get? The b value will be 4. Now what is our next step? Substitute the values of a and b in equation number 6. Now after substituting the values of a and b, we have got minus 1 upon s plus 1 and 4 upon s plus 2. Now, what we want? We want inverse Laplace transform. That is, we want a response. So, we are going to apply inverse Laplace transform on both the sides to get the value of ZIR of s. Now, what we want? Response. That's why I'm applying inverse Laplace transform on both the sides. Now, we know that if we apply inverse Laplace transform, then all the s domain will be transformed into a time domain. So this is nothing but YZIR of t. Now look at it. I'll take a minus 1 constant, which is a common part. Now apply Laplace transform, or you can say Laplace inverse. So this s is shifted by plus 1, which means here we will use a frequency shifting property, and according to that the a value is plus 1. So we'll multiply this value t with a minus a, and so minus a value is minus 1. So minus 1 into 2e becomes minus t. What is remaining? 1 by s, and the 1 by s inverse is a unit step. Now from next part, I'll take 4 common because it's a constant part. Now what we have? 1 upon s plus 2. Again this s is shifted by plus 2. Then of course we'll multiply this t value by opposite sign value of plus 2. And it is minus 2t. Now what is remaining? 1 by s, and 1 by s inverse is unit step once again. Now you can take unit step common, or you can u of t common. So what is remaining? Minus of e to the power minus t and plus 4 e to the power minus 2t. And this is nothing but our zero input response. Now what we are going to do? We are going to add a ZIR of t value and ZSR of t value in equation number 1. So let's say this is nothing but my equation number 7. Now from equation 1, what was there? Y of t was YZSR of t plus YZIR of t, and this combined will gives us a total response. Now I have substituted the YZSR of t and YZIR of t equation over here. Now from both these sides we have a u of t, so you can take u of t common. So all the brackets will be added with each other. We have 1 and it is a constant value. Next, e to the power minus t. Here also we have e to the power minus t. The coefficient is minus 2 and here coefficient is minus 1. So minus 2 and minus 1 gives us a minus 3. So we'll get minus 3 into e to the power minus t. Now here we have simply e to the power minus 2t and here we have 4 times of e to the power minus 2t. So if we add both the value, you will get 5 times e to the power minus 2t. And this is nothing but the output response of the system. So that's all for now. We have studied 6 numericals, whereas 3 numericals are based on a simple response where the initial conditions are assumed or considered as 0, and the next 3 numericals are based on 0 state response, 0 input response and total response, where we have considered the initial condition values. So just go through the videos, all the videos, and you will get the idea about what do you mean by transfer function, step response and impulse response, as well as ZIR, ZSR and total response. So thank you for watching this video. Stay tuned with Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.